cancer. And once you've had this area resected, then you could replace it by a metal implant, or you'll see today some work on bioresins, which are to replace metal. And also you can have soft implants. These are softer onlays, just to pad out the cheeks of the patient. It's not all medical scanning. You can scan metal items. If you are lucky enough to have a hospital locally and you have plastic items, you can sometimes persuade them to scan things for you. When you have a big block of metal, you cannot put it on a normal medical scanner. So people like Hitachi make these great big industrial scanners. When it doesn't show you, this is in a lead-lined room, and using 30 times the medical level to generate information. And typically resolution, depending on the field of view you use, it's only a 4-inch field of view, it's 0.1 of a millimetre. The bigger the field of view, the less resolution you get. The advantage of CT scanning is you get lots of interior details, including in some cases faults in your castings you didn't know about. The disadvantage is it's very high running costs. It's not something you generally buy for your own company. You tend to use somebody who's set up as a bureau. And some objects come radioactive after scanning, so it can be a disadvantage in some applications. Some up to thousands of years, so it can be a problem shipping the goods out. So there's an alternative technique, which is destructive reverse engineering, where you take the object, you encase it in resin, and then you mill it away. So you take your object, you place it in a say white resin, you mill away the material, and then a simple 2D scanner captures the geometry of the object encased in the resin. And it's quite a neat system in some respects, and can be fairly accurate and offer fairly high resolution. There are clearly some disadvantages. It destroys the part. So it wouldn't be useful for your Roman bottle or your 10,000-year-old plaque, or maybe even your motor racing engine for Formula 1. If you've got a serious production of engines, you don't mind losing one to get the data. You need to have a rigid, opaque object. And strangely, CGI never came up with a system for hard metal machining. They only sell their machine and the scanner. Why nobody ever just, why they don't sell it as a scanner to retrofit onto an existing machine tool is anyone's guess, because that would allow a lot more options. It's their business. Finally, we'll talk a bit about pressure mapping. We've talked about contact scanning and non-contact and volumetric scanning. For some products, you might want to conduct a pressure mapping exercise. Anybody here involved in making? We have a local wheelchair company that comes in from time to time. Anyone can imagine whether they want to use pressure mapping in their companies? So Richard, maybe Ford. You might want to pressure map and have a bespoke car seat for some VIP or for a motor racing driver. This is all about comfort. So what you might want to do is to sit, rather than scan somebody's backside, you might want to actually have them sit on a seat and measure the pressure. And actually, generally speaking, there's a relationship between the high pressure areas and areas which give pain. But not exclusively. It's not a simple equation. Some people have high pressure areas and are wonderfully comfortable. Other people have just moderately high pressure areas and are horrendously uncomfortable. So there's a little bit of psychology and pain processing. This is an example of a pressure sensing blanket from which has a sort of conductive grids inside, which is separated by a dielectric fluid. And as you press the grids down under pressure, the dielectric fluid compresses and allows you to change the resistance between the two grids. And that's sort of there's two pressure maps set up And an example would be, for example, a wheelchair, where if you're the customer is sitting in that wheelchair for 18, 20 hours a day, it clearly has to be as comfortable as possible. And that's the sort of image you might get where you've got pressure areas where you expect them. I'm not quite sure why there's a greater area of pressure there and in the back. Strangely, I've started to gather data. I found lots of applications you wouldn't expect. The ones you would expect are things like walking analysis, gait analysis. If you've got a problem with your posture, you can walk on these pressure maps, and you can check how your feet distribute the load, and then a trained person can actually help you with your posture, perhaps give you orthotic insoles to improve how you walk. Analysis of products with grips on. This is probably some sort of disabled mobility aid, and just assessing how the grips work. Pressure mapping of saddles, quite a big business, quite expensive thing. Pressure mapping of prosthesis, but also things like pressure mapping of brake discs. And you can place this element, this sensor inside, and then look at how the pressure is distributed across the discs. So not just about human body scanning. Within custom fit, the primary area where we used pressure mapping was on the seat for the Ducati. Where we took riders, they sat on the seat, and then for each rider we created a little pressure map. And then we modified the seat, and then asked them, is it better or is it worse? And most of it is better, and some of it is no better. It isn't a straightforward science, that's for certain. Another important thing, lastly, is we're talking about customised products. And for your business, you want to actually sell them at a price premium. And the best way of doing that is to actually ask the customer what they want. If they feel they've got a choice in that product, you'll be able to take more money out of their pockets for it. So always try and involve yourself with the customer. That local contact, that relationship is very important. It allows you to control the whole process and relationship and hopefully maintain business. Del, can I have a quick presentation here, just 2 slides, and then we're going to have questions and our coffee break. And it's much deserved.
And the demo.
Yeah, right. Come on, guys. Okay, everyone's very thirsty.
Right, I'll be swift. I've only got 1 slide, which is good news. Okay, I wanted to just introduce a demo that Ian's going to do. Before that, I wanted to pick up on something that was said earlier on. Jan Mullen talked about the training side of the custom fit project. What comes after that is the exploitation and being able to produce products and mass customise that are unique to every customer but done on a cost-effective way. Delcam, we've got 2 software products, one for dental and one for shoe orthotics. The dental one allows an implant to be made very quickly, designed to fit the bite, to fit the preparation from the dentist, and then be machined in a ceramic. Very quickly, very efficiently, there's big business there. Also, we have an orthotics product. Believe it or not, there's big business there where people want to scan the foot. We talked about gait analysis. They want to be able to scan the foot and quickly and automatically make a new shape by morphing a standard template to the foot of the customer, and then also being prepared to correct issues with the customer. So there's 2 examples of exploitation. Okay, David's talked a lot about reverse engineering. To me, reverse engineering means copying. You scan something, however you scan it, you then fit surfaces to it, and those surfaces fit within a tolerance to the data. Okay, shrink wrapping. The problem with that approach, even though it's very powerful and very quick, is that when you put it into the CAD system to make it or do anything with it, it's an amorphous blob. There's now a trend towards what's called re-engineering, and what re-engineering is about is placing reverse engineering into the CAD system, into the CAD environment. So you take your point cloud data and your polygon models, and you work in a CAD environment in a traditional way. So instead of having a free-form shape describing a circular form, it might be a surface of revolution. So you're using CAD techniques to create a better fit.